Okay, so this is 13.4. This has to do with slope and rate of change. Okay, so really, when you're talking about the slope, you're really talking about the inclination or the steepness of the line. So the slope is just the steepness. Steep. Sorry, can't spell it. That's not unusual. Steepness. I don't know where that is. Steepness there of the line. Okay. Now, when you're talking about linear equations, okay, I'm going to put a little graph. Okay. All right. Here's your x-axis, and here's your y-axis. Okay. All right. Lines are going to when you're reading graphs, you read them from left to right. Okay. So as a line moves from left to right, it's going up. Then the slope, and we use the letter M to indicate slope. The slope is positive. Going down from left to right, the slope is negative. All right. If it's a horizontal line, the slope is equal to 0. If it's a vertical line, okay, we say that the slope is undefined. Okay, so those are the 4 scenarios that you're talking about when you're talking about slope. Okay, but you can kind of see it, or you're just talking about the steepness of the line. All right, so that's basically when you're looking at these things, the direction of your slope is going to fall into one of those 4 categories. Okay, now the line can be, that the steepness is going to change, a lot on what it is. So when you're talking about finding the slope between 2 points, right, what you want to do is you're going to use something called the slope equation. Okay, and the slope equation, they have M is equal to y2 minus y1 over x2 minus x1. Okay, so you have this equation. Okay, and when you're talking about finding the slope between 2 points, you're basically looking at, if you got 2 points, now points consist of an x and a y coordinate. Okay, that subscript, like this would be x1, y1, this is x2, y2. Basically, that's what you're doing with is the subscript here, just saying, hey, this is point 1 and this is point 2. Okay, and that's pretty much what you're talking about. All right, we're going to get into it a bit more. Okay, here in just a minute. All right, so a lot of you have probably heard that the slope is basically the rise over the run. Okay, the run is moving, from left to right, and the rise is going up and down. Okay, depending on, how you read the graph. All right, and really, when you're talking about this, it's the change in y over the change in x. That's Greek letter delta. Okay, so, and when you're talking about that, this is really what you're doing. Okay, the change is the difference from one point to another point. Okay, and that difference is the steepness. The slope of a horizontal line, okay, like I told you before, is equal to 0. Okay, because when you're talking about a horizontal line, remember, this is the rise of the line. Okay, and a horizontal line, it's all run and 0 rise. It's not going up or down. Okay, so you're going to end up with the slope is equal to 0. The slope of a vertical line, okay, remember, that's still the rise over the run. Okay, but in this case, it's all rise because it's just going straight up and down, and 0 run. And the division by 0 is going to be undefined. Okay, so like I said, it's one of those things that you just have to memorize which one's which. Okay, there's a lot in this section that it's either this or it's that. People get them backwards all the time. Okay, so when you're looking finding the slope of the line. Hey, they give you 2 points. Okay, you plug them into the slope equation. Okay, remember the slope equation is really, really big equation. You use it in graphing, it's like everything. Okay, so what I'm going to do is I'm going to say, okay, you can be x1, y1, and you can be x2, y2. And I'm just going to plug them in. So I get m is equal to 12 minus 7 over 2 minus 5. Okay, I'm going to get 5 on the top. I'm going to get negative 3 on the bottom. Okay, now I'm going to write this as negative 5/3. That means for every 3 units I move to the right, I'm going to go down 5 units, and that's what that negative is telling me. Okay, if it were positive, then I'd move 3 to the right and then up 5. Okay, so when you're looking at this next one, okay, same thing, x1, y1, x2, y2. It doesn't matter which one I call point 1 and point 2. Just don't mix and match. You know, don't put x1 with y2. So that wouldn't work. Okay, so what I'm going to do is I'm just going to plug them into the equation. But for this, remember, you got to be a little bit careful because I'm saying negative 5 minus negative 4. Okay, and then I've got negative 3 minus 3. Now you know what this is going to do. It's going to be like adding. So negative 5 plus 4 is going to give you negative 1. And then negative 3 minus 3 is going to give you negative 6. So you're going to get 1/6 out of the deal. Okay, you're done. So when you're looking at number 3, do the same thing. x1, y1, x2, y2. Negative 2 minus negative 2 over 4 minus 1. Okay. When you do that, that's going to be added. So negative 2 plus 2 is 0. 4 minus 1 is 3. So you're going to end up with 0 divided by 3 is a 0. Okay. So, you know, this is a horizontal line these things are on. Okay. So what I'm going to do for number 4, I'm going to do the same thing. Okay. x1, y1, x2, y2, plug them in. 0 minus negative 6 over 5 minus 5. It's going to give me positive 6 over 0, which is division by 0 is undefined. Okay. Now, if you can remember this will save you some trouble. Okay. When the y's are the same, okay, you know it's going to be a horizontal line. When the x's are the same, it's a vertical line. Okay. If you can remember that. If not, don't worry about it. Just plug them in. It's still going to come out. Just know what the slope of a horizontal line is 0, and the slope of a vertical line is undefined. It rhymes. Okay. So let's go and open up. So we got this thing. Okay. And this is what you're going to get. All right. So instead of using the equation, we can just figure out what the slope is right off the graph. Okay. The only thing is you need to find 2 points that you can really delineate or discern. Okay. And the points that you know are, you see these little hatch marks right here and right here. That point there, you know exactly what that point is. Okay. So so when I'm looking at this one, I know what that point is. Okay. And so I'll just go down the line until I find another one. I know what that point is because it's falling right there in the intersection of those little dotted lines. Okay. So this is like 0 and 4, and this is like 4 and negative 2. Okay. So you could take those and plug them into the slope equation and come out with the slope, or you can just make it a lot easier. Okay. And you can say, hey, how many do I need to go over and how many do I need to go down to get from this point on the y-axis to this point? It's like, okay, so I'm going to go over 4. So that's on the bottom because you're moving left to right. And then how many do I need to go down? I need to go 2, 4, 6 down. Okay. Now, the only other thing you need to do is you need to reduce this fraction here down to 3 halves. Okay. And you're done. So this is a horizontal line. So you don't even really have to think about it. You just got to remember, hey, the slope is 0 for that. All right. So take a shot at number 7 here. See if you can do it. And so pause the video. See what happens. Okay, then come back. So what I'm going to do, I know this point and I know this point. So m is equal to, how many do I need to go over? I need to go over 2, 4, and then I need to go up 2, 4, 6. Okay, so this is going to be positive 3 halves. I made a boo-boo over here because we went over and we went down. So that's like we went down 6. I didn't put that there. So down 3 halves. Okay. So sorry about that. But so you can kind of see where you can just read it right off the graph. And you can you don't have to plug anything into an equation. And it's a lot faster too. Okay. So the next one you got here says the equation of the line is slope intercept form. Okay, so you know that the slope equation, that's a big deal with graphing. Okay, this equation is a big deal. Okay, it's a lot of stuff. You know, if you had like a calculator, you'd plug it in using this equation. You plug your equation in the calculator and graph it that way, which you'll have to do in the intermediate. But let's just go over this really quick. Okay, X and Y here are just where you plug coordinates in. Okay. M is going to be your slope. Okay, so this is your slope. B here is a little bit different critter. And what I'm going to do is I'm going to go back up here. Okay, and explain what B is. Okay, B is the Y coordinate of the Y intercept. Okay, so this is the Y intercept, right? The coordinates for that thing there is going to be 0, -5. Okay, so you're looking at this as being X and Y, but this guy here is also understood to be B. Okay. Now, when you look at any other place on here, okay, you've got an X and a Y coordinate, but none of those Y coordinates are B. Only the Y intercept is the Y coordinate B. Okay. So basically what it comes down to is when you're looking at a coordinate like this one, 0, -5. If the X isn't 0, then the Y is not B. Okay, so yeah, you got to make sure that you kind of get that gist. Okay, so what I'm looking at here is they're going to ask you, hey, what's the slope and what's the Y-intercept of each following lines? So you know that the slope here is 2/5. Okay, I know the Y-intercept. Okay, it's going to be, what do you know about the Y-intercept? X is 0, and that's going to be, that's your B, so you know it's the Y coordinate. Okay, now on number 2 here, this is not in the slope intercept form. Remember, it's got to be in this Y is equal to mx plus b form. Okay, for you to say, oh yeah, this is the slope intercept equation. Okay, but you can put it in that form really easy by just getting Y by itself. So subtract 5x from both sides. We get 2y is equal to -5x plus 2. Now let's divide by 2, 2, 2. You get y is equal to -5 halves x plus 1. So what's the slope here? Well, the slope is negative 5 halves. Okay, remember, it's just that coefficient in front of x. Don't include x. Okay, and the y-intercept is going to be 0, 1. Okay, in your program, sometimes they'll ask you for the y-intercept, but they'll just want you to put in the y-coordinate. They won't want you to put it in as an ordered pair. And sometimes it's really confusing as to which way they want it. Okay, so if you look at number 3, okay, there's no y in here. Okay. You just got x equal to some constant number. Remember, this is a vertical line. Okay. What's the slope of a vertical line? It's undefined. Okay. Remember, it rhymes. Okay. What else did I tell you about vertical lines? They don't have y-intercepts, okay, because they're not going to cross the y-axis. So, you know, when you're talking about the y-intercept, you say basically NA, all right? But you don't have one, all right? Number 4 here is a little bit tricky because they got x is equal to 10y, all right? Remember, you want y is equal to mx plus b. So they got things moved around here, so it can be a little bit confusing. So what I'm going to do is I'm going to get y by itself. So I'm going to divide by 10. Okay, so I got x over 10 is equal to y. Now it's still a little bit kind of weird because you haven't seen a lot of this. So I'm gonna write it like y is equal to x over 10. Remember that the coefficient in front of x here is 1. So that's like me saying y is equal to 1/10 x. Okay. The other thing about this is when you're looking at this, there's no plus something or minus something. That's because it's 0. Okay. So what that means here is this. Okay. It's saying, hey, the slope is 1/10. The y-intercept is going to be, well, there's not a b here. So b is understood to be 0. So it's going to be 0, 0 is your y-intercept. Okay. So it can kind of throw you off a little bit if you're not careful, because you've everything we've done up to now is kind of got that y is equal to mx plus b, and then we switch things around, and it's easily, you know, you can get confused with it. So let's see here. Uh-oh. Yep. You have to keep me off. Well, that was not very nice. I'll have to look it back up. So give me a second. I'll have that. So this, share, click, okay. And let's pull it up. Okay, there we go. So make it a little bit more. Okay, so on these, they're just giving you some extra stuff here. So remember on number 5 here, this is a horizontal line and there's no x here. So what we'll do is we'll just get y by itself, and we'll do that by adding 5 to both sides. So we're going to get y is equal to 5. Now you got to know that the slope of a horizontal line is 0. Okay, and the y-intercept here is going to be 5. So it's going to be 0, 5. The way this works is this. Let's say we got y is equal to, I know that the slope is 0 here because I'm looking at a horizontal line. So slope is 0, x, and then I'll put plus 5. Well, 0 times x is going to be 0, so you're just going to end up with y is equal to 5. So you're really looking at the y-intercept there. So the y-intercept is going to be 0, 5. All right. Number 6. I didn't tell you this earlier, but when you see things like that are in this form, okay, this is what they call standard form of a line. Okay, and A and B are just coefficients, and C is some constant number. Okay, now you can see them in all kinds of stuff. Okay, just because they have AX plus B doesn't mean that it's not, you know, you couldn't have something like 2x minus 3y is equal to, you know, 7. Okay, it just happens to be that B is a negative number. This is, remember, it's just a general type of rule. All right, but the other thing is when you're talking about standard form, don't think this B here, you'll see this somewhere written. Okay, that B is not your y-intercept. Okay, it's a big B. All right, so it's just a coefficient. Right? So don't get it confused with other stuff. Okay, so remember when you're dealing with graphing lines, when they're in certain forms, the coefficients or the constants or whatever, okay, they mean certain things. Okay, for the most part, when you're graphing, if you know what M is and you know what the y-intercept is, there's not very much they can ask you that you can't answer. Okay, so for this one, remember, I'm going to get y by itself, so I'm going to subtract x on both sides. So I get y is equal to negative x plus 3. All right, my slope here, remember, this is negative 1. So my slope is negative 1, and my y-intercept is going to be 0, 3. All right. Number 7 here, they just have things in a reversed order. So I'm just going to take it and say x, negative x plus 9. So your slope here is negative 1, and your y-intercept is going to be 0, 9. All right. Over here, remember, when you have x over 3, that's the same as me writing 1/3 x plus 5. So my slope here is 1/3. Okay. And my intercept is 0, 5. Okay. Number 9 here, remember, there's no number over here. So this is like plus 0. Okay. They just don't put that there. So you know that your y-intercept is 0. And your slope here is 1. Okay, so M is equal to 1, and your y-intercept is going to be 0, 0. And you're done. All right. So you need to just, you know, kind of look at some stuff and make sure that you kind of get everything when it's, you know, what's the slope equation? What does that x1, y1 bit mean? When you're looking at the slope intercept equation and you want it in this y is equal to mx plus b, because remember, when it's in that form, you know what the slope is and you know what the y-intercept is because you're staring at it. Okay, so I think that's all we got. Yeah, nothing left in there. Okay, good luck with it.